Hi, and welcome to the Total System Performance Ratio TSPR training as part of the Washington State Energy Code training series. My name's Heather Burpee, and I'll be one of your presenters today, and we're really happy to have all of you guys join us today. The agenda for today is that we'll be talking about TSPR. I'll give a brief background about TSPR. Then we'll have a click-through training on one of the tools that can be used to analyze TSPR. We'll go through an output report from that tool, and we'll talk about next steps. At the end, we'll go through a Q&A. Some logistics of getting through the webinar today. First, please stay muted during the presentation. That probably was an automatic option, so you probably don't need to do anything differently than you already are to stay muted. You can add questions through the Q&A section, and we'll be monitoring those throughout the presentation, and we'll publish unique questions and then address those at the end of the presentation. You can upvote questions that you hope to be answered at the end of the Q&A. So if you see someone else ask a question that you also want to know the answer to, you can add a +1 to that, and those will go higher up in the queue. And you can also add things to the chat, but we won't be monitoring those for the Q&A. So a little introduction of the presenters today. I mentioned my name's Heather Burpee. I'm with the University of Washington Integrated Design Lab, and I'm faculty at the University of Washington in the Department of Architecture. And one of my roles, the Integrated Design Lab, is to provide education and outreach. So that's what I'm doing today. Supriya Goel is a senior research engineer at the Pacific Northwest National Lab, and she was involved in developing the asset score tool and the TSPR tool, and will be helping us with the click-through training today. Duane Lewellen is the owner of Lewellen Associates and is an energy consultant located in Linwood, Washington. And he'll be helping us with the Q&A at the end and helping us with some of the technical backside of the webinar today. So I'd like to thank my co-presenters for joining me today. And also thank you to our sponsors. NEA has sponsored this educational program, and NEA is a regional alliance of more than 140 Northwest utilities and energy efficiency organizations, including BPA and Energy Trust. NEA was incorporated in 1996 as a regional collaborative tasked with pursuing the highest value activities to secure energy efficiency for the region. Their funders represent more than 13 million energy consumers in Idaho, Montana, Oregon, and Washington. And their 80+ staff are located in Portland, Oregon, and also work with contractors that are throughout the region. So thank you to NEA for sponsoring this event today. So what is TSPR? TSPR stands for Total System Performance Ratio, and it's a ratio of annual heating and cooling loads compared to the annual carbon emissions associated with the energy consumed by the HVAC system. You can see that equation here. And we're going to dive more into that in a few minutes here, but I want to talk about what's the main goal of TSPR, and really it's to encourage low emission systems. And in Washington, that is electric systems. It's aligned with Washington state policy goals of low carbon emissions. And it's new to the 2018 Washington State Energy Code. The target date for the new Washington State Energy Code has changed a couple of times, and now this will apply to projects permitted after January 31st, 2021, because the code will be adopted on February 1st. Where does TSPR fit into code compliance? Some people are talking about that it's the missing link between the prescriptive approach and whole building performance modeling approach. So prescriptive requirements are the base requirements that must be met by all systems. I want to note here that the 2018 Washington State Energy Code prescriptive requirements have also become more stringent. So you might see that TSPR is more stringent, but that is partially because the prescriptive base level performance has also increased in this code cycle. The whole building performance path is where there's one energy target for the whole building. And then in some jurisdictions, we have outcome-based codes or prove it with performance type codes. So whole building HVAC compliance, or TSPR, fits between this prescriptive and whole building approach. Prescriptive codes evaluate individual components of a system, such as chillers, furnaces, cooling coils, pumps, etc. And one of the valuable things about TSPR is it allows for a more holistic or complete evaluation of an HVAC system, and includes the impacts of the entire system as a whole, including the fans, the pumps, heat recovery, heat rejection controls, etc. We're familiar with this kind of approach for lighting or envelope systems. TSPR adds this capability for HVAC systems. Hence, like a component-based prescriptive approach, the system efficiency approach accounts for these interactions between the different components of the system. But unlike the whole building performance, it does not allow trade-offs between systems. So for example, with an HVAC system performance approach like TSPR, a user can't trade off envelope insulation for a more efficient HVAC system control. So another way to say that, trading off between a long life measure with a shorter life measure. The system performance, or TSPR, limits trade-offs within the pertinent systems, the HVAC system components. This is another way to look at it, where we're doing an analysis for the whole building, more like a seasonal heat pump rating rather than a boiler rating. So we're used to seeing ratings for individual pieces of equipment. This is a rating for the whole building. So a little bit about the development of TSPR and the stakeholders and the timeline. This was envisioned way back in 2012. PNNL thought about the idea of whole buildings HVAC system efficiency based on a ratio of annual heating cooling loads compared to energy use. And that concept was implemented within the asset score tool in 2015. In 2017, NEA came on board and started talking with Washington State Energy Code developers, and PNNL brought this idea of TSPR to the group, and it was decided to move forward as one measure that NEA would advance. So then between 2018 and 2020, NEA led some stakeholder engagement around TSPR, and decisions were made about how it would be implemented. And stakeholders, ranged from different disciplines and geographic areas across the state, meeting with utilities and other code stakeholders on a quarterly basis, with a technical advisory group and other stakeholders to decide what the actual equation would be. And it was decided to actually use carbon emissions rather than energy use as the denominator. And then there will be ongoing engagement with NEA to help align TSPR with code and utility programs and market needs for best practice as this moves forward. So why TSPR? TSPR drives down real HVAC energy use and carbon emissions, and it rewards integrated and efficient system design. There's a free calculation tool, which we'll talk about, that allows for simple, streamlined scoring, and it can be tailored to jurisdictions or utility programs. If a jurisdiction chose to have a more stringent threshold for passing, that is a way to have it tailored specifically for that area and make the result more aggressive or more energy efficient or lower carbon emitting. These images at the bottom are depictions of what is happening, and it's not happening today, but we'll all remember these fires that happen in Australia. Climate change is real. So the intent is to align with the Washington State energy goals and carbon emission goals with an eye to reducing carbon and environmental footprint. So a little bit more about this equation and how TSPR is calculated. Essentially, it's the sum of the HVAC coil loads. So if you're familiar with Energy Plus, that would be the ideal loads, or in DOE2, the sum of the zone loads. And then those are divided by the sum of the annual carbon emissions related to heating, cooling, fan, pumps, energy recovery, and heat rejection. If you pass, your proposed ratio must be greater than or equal to a baseline ratio. We'll talk about both the definition of carbon emissions and the baseline ratio in just a minute here. And also, in order to pass, you have to meet all other HVAC code requirements. So a little bit more about the carbon assumptions. This is taken from the Washington State Energy Code Table C407.1, which specifies the carbon emission factors to be used to determine compliance. So these are the carbon emission factors that are used statewide to calculate the TSPR ratio. And you'll see in that table, there's the fuel type, the units, and the pound per unit equivalent, and the units. So you know what assumptions go into that calculation. TSPR is similar to ASHRAE Appendix G, if you're familiar with that. The baseline is a reasonably efficient system for each building type. We'll talk more about that in a second. Your city's code baseline might be different. And there's just one stable baseline. It's not changing for each system type or code edition, but it has some differences. The trades happen within the HVAC system only, and it's not trading better HVAC for worse envelope, for example. We talked about that a little bit. And there's a calculation tool that can be used. So we'll do a click through of that calculation tool, and it uses a simplified building geometry and default values in many cases. So what projects require TSPR analysis? So essentially the code, this is pulled from C403.1.1 of the Washington State Energy Code. And there are 4 building typologies that must go through the TSPR analysis. And those are offices, retail, library, and education occupancies. Now, so if you're one of those occupancies, you'll have to go through this analysis unless you meet one of these exceptions on the right. And so I'm going to talk a little bit about these exceptions. So buildings with conditioned floor area less than 5,000 square feet do not have to go through TSPR. Systems connected to district heating water or chilled water or steam don't have to go through this. HVAC systems with absorption chillers, heat recovery chillers, water heat pumps, some other central plant systems do not need to go through. The systems that have underfloor air distribution, alterations that do not substantially replace the entire HVAC system, and those that meet the base requirements of the standard reference design that's used in the baseline. And we'll go through a table that shows that in a second. There's also a provision here that I skipped over that says that any HVAC system not included in table D601.11.1. So I'll show that table in just a minute to say what systems are included. It's important to say here that some of these exceptions were included primarily because there wasn't the budget or bandwidth to be able to fully analyze these system configurations to get them included in this code cycle. So in some future iterations, those exceptions might be inclusions in the future. So here is this table, the D601.11.1, the HVAC system supported by the TSPR tool. And what I really should say is HVAC systems that do go through the TSPR analysis or are required to go through the TSPR analysis. And so you can see those systems here, or you can reference the code. So a little bit more about the baseline HVAC systems. These baselines were determined by some of these stakeholder groups that I mentioned previously in a series of working group meetings, and they came from different disciplines. And the baselines are efficient, and they meet the new baseline Washington State Energy Code requirements for DOAS, combined with cycling space conditioning systems and energy recovery ventilation. And those baselines are written into the Washington State Energy Code. And so for each typology, there's a different baseline. You'll see those four required typologies below, and an example of the system that's the baseline system. Something that you'll see as a commonality is their heat pumps at the core. So that's an important change in the energy code, that the energy code has become more efficient for the baseline system. Another way to look at this is in the code table D602.11. This is the standard reference design HVAC systems. So this outlines all of the requirements for the baseline system to meet or exceed TSPR. So you can see it's not just a heat pump. It includes fans, the cooling source, heating source, outside air, economizer, ERV efficiency, etc. And so those minimum values, the baseline values, are listed in this table. And if your design meets or exceeds that, it will pass TSPR. So with that, I'd like to pass the baton to Supriya, and Supriya is going to provide us a little bit more background and then do a click through of the TSPR analysis tool. Thank you.
Thanks for the introduction, Heather. Hi, everyone. I will walk you through the compliance tool that has been developed for implementing the TSPR requirements in Washington State Energy Code. And after that, we'll go through a demo of the tool where we'll create a building, assign all components to the building, and generate a report and have a look at what the report tells us. So to give you a brief introduction of the tool, the TSPR capability has been added to DOE's Building Energy Asset Score tool, which has been developed by BNNL. The Asset Score tool is a web-based tool. It's an extremely simplified tool for assessing building energy efficiency. So like you see in the screenshot here, it provides an interface where you can create a simplified geometric representation of your building. The tool also uses default loads and schedules as defined by Washington State Energy Code, and these are based on the use types for the building. And the tool has the capability to automatically generate the baseline for the TSPR analysis, and the baseline uses the exact same envelope, lighting, schedules, and loads as the proposed building. And based on several tests that we have done, pilot tests, beta tests, the feedback we've received is that this tool significantly reduces the amount of time it takes to generate an energy model. So it can take less than 10% of the time a fully customized, detailed energy model might take. And during the demo, I'll point out the things the tool implements and the capabilities within the tool which actually allow you to use less time to generate an energy model. To give you an overview of the actual workflow of the tool, so this is a web-based tool. It has a user interface through which you would define the building. And to define the building, you would create the building geometry. There are several predefined shapes that you can use specified dimensions for, and then just group them together to create a geometric representation of your building. The envelope properties would be defined, and as specified in the Washington State Energy Code, the code defines what the construction needs to be. So the user is actually just specifying the assembly U factor, solar heat gain coefficient for all the different envelope components. Lighting power density is based on the use type for the use type of the building. So it's prescribed and it cannot be modified. And the HVAC system is where you would spend bulk of your time specifying the HVAC system properties for the building. So once the building description is complete, you would submit the building for analysis. The information is sent to PNNL server, where we run OpenStudio and Energy Plus to create the proposed building model. And we then apply the TSPR rule set on the proposed building model to automatically generate the baseline. And as defined in the code, the baseline uses the exact same building geometry, envelope, lighting, schedules, and loads as for the proposed building, but just replaces the HVAC system with the baseline HVAC system as defined in the code. And then we do another run for the ideal loads analysis. So again, we use the exact same geometry, lighting, envelope, schedules, and loads as the proposed building, but replace the HVAC system with the ideal loads HVAC system and do an ideal loads run. For people who are unfamiliar with the ideal loads air system, this is essentially a capability in Energy Plus where you can calculate the annual heating and cooling load for a building. So assume a system with 100% efficiency was meeting the load. The result of that is essentially the ideal load. And then we calculate using all of this, all of the results of the proposed building HVAC energy used by end use, the baseline building HVAC energy used by end use, and the annual heating and cooling loads from the ideal loads run. We calculate the proposed TSPR and baseline TSPR. All of this information is compiled into a PDF report, which also summarizes, along with the TSPR results, it also summarizes the whole building energy use by end use for HVAC systems, and then also provides this information for all unique system types in the building. Once the report has been generated, a user is notified through email, and they receive a link at which they can access the report. So to give you a brief overview of the tool, like I said, this is a web-based tool which can be accessed at buildingenergyscore.energy.gov. You would need to register to use the tool. The registration process will verify your email address. The tool works best on Chrome and Safari browser. If you use Firefox or Internet Explorer, you will see some user interface issues which are due to some inherent capabilities of the browser, and the tool doesn't work well on them. When you register and your email is verified, after which you can log in, there are these 3 tabs for Asset Score, TSPR, and Audit Template. And TSPR is the one you would click on, and then you would click on Add a Building to create a building. You can specify the building name, location, and the zip code, etc. And then it will take you to this screen where you can create the building geometry. So during the click-through demo, we'll actually go through the process of creating a building. So then you can see the kind of inputs the tool asks for and how the geometry creation works. After you've created the building, you can go and create the building envelope components. And again, it's a very high level input where you're defining the assembly U value, solar heat gain coefficient for windows, and then you can simply drag and drop it on a block to assign it. And when you click on a block, the tool will tell you what properties have been assigned. Lighting, like I mentioned, is prescribed and it's not a user input. So in the lighting tab, you can just click on a block and it would tell you what lighting power density has been assigned to that block. In the HVAC screen, you can create air handlers, zone equipment, plant loops, specify properties for the same, and then drag and drop them to the block. The tool has extremely robust error checking and input validation checks. So basically, if you were to specify a value, just in error, if you were to give a value which is extremely incorrect, like a COP of 20, the tool will prompt you that maybe that this is an incorrect value, and it would require you to specify a value which is within the min and max limits of that particular input cell. Similarly, if any value is missed, so in this case, we see that COP is a required field, you cannot submit a building without entering all the required values, and the tool will verify all of those, all of that. Once the data entry is complete, you can click on Score Building. The building will be sent to PNNL servers for analysis, and a PDF report will be generated and sent to you through email. So this is just an example of a large office building which was analyzed using the tool. This building was analyzed. So the first result that you see is for the Washington State Energy Code baseline, which is a water source heat pump with DOAS and ERV. And this receives a TSPR of around 15. Again, we're using carbon emissions for electricity and gas as defined in the code. And we analyzed the same building with several different HVAC systems, a minimally compliant fan coil unit with DOAS ERV, where the DOAS had a sensible effectiveness of 50%. As you can see, this minimally compliant fan coil unit does not meet the TSPR requirements, and we had to improve the fan coil unit with improved efficiency, higher effectiveness DOAS, and then improved chilled water and hot water pump power to get it to comply. Similarly, we analyzed the same building with a minimally compliant VAV with hot water reheat system, but had to improve the system with chilled water, with improved pump power for chilled water, hot water system, higher efficiency for the chiller, and then DCV and a lower minimum airflow fraction in order to get it to comply. So this basically indicates that the TSPR tool is able to identify efficient system configurations, and a building which goes beyond the prescriptive requirements is able to comply through the TSPR requirements. And this analysis was done for several use types. And we also have such example buildings created. So if you're interested, we can share those buildings with your account once you register to use the tool. This is just a sample output report. Through the click-through demo, we'll actually create a building and walk through a detailed sample report. At a high level, the report has a lot of information. Of course, it provides the proposed and baseline building TSPR, and it also identifies, based on these results, whether the building complies with the Washington State Energy Code. It has 4 other sections. The first section identifies the whole building HVAC site energy use by end use, the heating and cooling loads. So here, this information is given for the proposed and baseline building, and you can compare and see which end use is effective, is efficient, which is not, and you can think about improving the mechanical system accordingly if it doesn't comply with TSPR requirements. The tool also generates the same information for each unique system type in the building. So you'll get the system level loads and HVAC energy used by end use for the different systems. So for example, if you have a building with a rooftop heat pump and a rooftop gas furnace, and you're building at a building level, you do not meet the code requirements, the proposed TSPR is lower than the baseline, the tool will tell you what the TSPR for the 2 individual systems are, both the heat pump and the rooftop gas furnace, and you can then see which system needs to be improved in order to comply with the code requirements. There is also a mechanical system schedule information that's added to the PDF report. So the tool has a capability where you can define the as-designed systems in a building with the rated capacity, rated efficiency, and a unique ID. And this information is printed out in the PDF report, and this helps the reviewer verify information against design drawings. The tool also summarizes baseline system details, so the baseline that was used to run the analysis for your building, that's also summarized in the PDF report. We'll now go through a live click-through demonstration of the tool, and like I mentioned, you should use Chrome or Safari to access the tool. We'll create a building through the tool, and we'll also go through the process of defining the mechanical equipment schedule, assigning HVAC systems, and then we'll walk through a report for that building and see all the results that the tool generates. So in order to get started, you would need to log on to buildingenergyscore.energy.gov. you would need to register if you do not have an account yet. In order to register, you can just go to the website, click on the registration link. It would require an email address, and it will verify your email address by sending you an email. Once you've created an account, you can come here and log in and get started. So TSPR tool works best on Chrome and Safari. All the other browsers are going to give you some issues, so we recommend just using Chrome or Apple Safari to work with this tool. Once you've registered and your email has been verified, you can log into the tool. You would come to a screen which looks somewhat like this. I have a bunch of buildings created. For you, it would be blank if this is the first time you're logging in. There are 3 capabilities in the tool: Asset Score, TSPR, and Audit Template. You would click on TSPR, from which you can click on Add a Building to create a new building. I will open up a building I have already created and walk you through the inputs. Once you have buildings created, they would be displayed in this table. This is what we call the list view. It tells you the status of the building, whether you've already analyzed it, in which case it has a report associated with it, the date it was modified. TSPR tool also allows you to share buildings. We won't get into the details of that yet, but if within an organization, you can share buildings within other users of the tool. And there are several options for you to duplicate a building, delete a building, or through this button, you can also share the building. So to create a building, once you click on Add a Building, you would specify the building location and a building name, and then the tool will bring you to this screen. I have already created the building geometry, but for you, it would be a blank building, and you can get started by clicking on the plus button on the blocks, on the block tab, to create a geometric shape. There are other tabs that you see on the top panel. Each of these allow you to specify a property of the building. So there is use types, construction assemblies, lighting, a mechanical equipment schedule, then assigning that heating and cooling equipment to the building, service hot water and operations, both of which are not available for TSPR, and then a final information tab, which summarizes all the data that you've entered for the building. So the first step would be to create a building geometry. In order to do that, you would click on the plus button. You can specify a name for that block and select from one of these predefined shapes, and then enter the dimension for that shape. So I'm going to create a rectangular building, which is 100 feet by 100 feet and 2 floors, with the floor-to-floor height of 12 feet and a floor-to-ceiling height of 9 feet, and I'm making this above ground. Once I create this block, it gets displayed over here. And like you can see, I can move this block around. I can also, there are these other capabilities for guides and snap, which you can use to place this block at a specific distance with respect to other blocks. And the snap button, which helps you glue the blocks together. Now, you must have noticed these orange exclamation marks that have come up on my other screens. This essentially indicates that there is some missing information. Like, for instance, the new block I created does not have a use type assigned. You can add a use type by clicking on this plus add use type button. And within every screen, you have access to the help desk, to the user guide, to which you can access from the question mark over here. Which will open up a separate tab with information on what that particular screen requires. Now, to add a use type, you can select from a drop-down of predefined of the specific use types that are supported for TSPR analysis. Because we have office and retail already created, doesn't get displayed in the drop-down. The other options are education, library, and multifamily. Multifamily use type is not required to undergo a TSPR analysis, but it is required by Seattle code, which is why it's available here. You can select on a use type, click add, and it gets added to the left-hand panel. Here you can see there is 0% of total building area, but because it has not been assigned to any block. In order to assign it to a block, you would simply drag and drop it on a block. It gets assigned, and the left-hand panel gets updated with the total the total square footage that's been assigned, and the percentage of the building area. Then moving on to the next tab, which is construction. Here it tells me every block must have an assigned roof assembly. So in order to know what construction types have been assigned to a block, you can click on a block, and it tells me that block 2 has roof 1, wall 1, window with the 10% window to wall ratio, and a floor. And on the left-hand panel are all the construction components I have created. So in order to create a new component, you would simply click on the plus button, give your component a name. This is an exterior roof, and you can specify the assembly you factor. And then click create. Now every component also has inbuilt tool validations. So if you were to give this a completely incorrect value, the tool would prompt you that this is too low and you need to enter a value greater than a specific low value we've built in. And then once you have all of these components created, you can drag and drop it on the geometry. Now, one thing to note that construction assemblies need to be assigned to all blocks. The tool automatically identifies interior surfaces. So for an interior wall, if you assign an exterior wall construction to it, the tool will automatically recognize that this block is adjacent to another block, so it needs to have an interior wall assembly, and it will model it with the appropriate interior construction. But in order to satisfy all the tool validations, you do need to assign all a construction component to it. So I will go ahead and assign a wall, a window. When I assign a window, I need to specify a window to wall ratio. And then I will assign a floor. Here I'm assigning an exterior floor to the block. And as I mentioned, the tool will recognize that there is only the small portion of the floor which is exterior, and all the other portion it will model as interior. Once all of the validation errors have been addressed, we can move on to the lighting tab. Lighting, based on Washington State Energy Code, lighting is prescribed based on the use type, and it cannot be modified. So this is an office use type. You can see the lighting power density has been fixed to 0.66. For retail, it's been fixed to 1.01 watts per square foot. So nothing needs to be done for lighting. We can just move on. This is what we call the mechanical equipment schedule. This is a new feature that's been added to the TSPR tool. If you've previously used the tool, you might not have seen this feature. Over here, you will go and create a mechanical equipment schedule as the name indicates. So you will create a row for each piece of equipment that's present in your building. You would specify the quantity, its rated capacity, and its rated efficiency. The tool automatically calculates the value shown in the blue column, which is it converts the rated efficiency from the units you have used to thermal efficiency and COP, which is used by the simulation tool. And then you can assign this system to a grouped system. So Washington State Energy Code requires similar system types to be grouped together, and you can calculate a capacity weighted average efficiency for that grouped system. This allows you to simplify the way building geometry is defined and the blocks that are created. So you can go ahead and create individual schedule entries and then assign it to a grouped system. So I will show this process for an air handler, and then I'll show you how it can be assigned to a grouped system. So the top table is showing you all individual pieces of equipment, and the bottom table has all the grouped systems. We will create an equipment. So I clicked on add equipment, and here I would specify a unique equipment ID. So let's do package single zone heat pump, and I'll add the number 4. There are 2 pieces of this equipment. Packaged heat pump. Cooling source is TX and heating source is heat pump. And specify a capacity in BTU per hour, and then the efficiency. And for the heat pump, again, I can specify a capacity, rated efficiency, and then the design airflow. So for this, we can specify 1000 CFM with a fan power of 0.6 watts per CFM. And then I can click on Save Air Handler Schedule Entries. Once this information is saved, the rated efficiency that you've specified will automatically be converted to COP. For packaged equipment, the tool also subtracts out the supply fan power. And then I can also put this in a grouped system. So like you see over here, the orange column is where you can group similar systems into an air handler. And this is a heat pump. So the tool tells me the only valid system I have, which I can group this in for, is a heat pump system. I can also create a separate system where which I want to use to group individual pieces of equipment in. So let's say I create a heat pump system. So, and I can then specify the cooling source and the heating source. So here you see it shows me existing unassigned mechanical equipment schedule entries applicable to the system, heat pump 1 and heat pump 4. So heat pump 4 is the one I just created. I can click on this paperclip icon to attach it to this system, and this gives me a grouped system. Once I click on Create Air Handler, it will display this system. This is the one I created with the calculated efficiency, which is the capacity weighted average of the two individual schedule entries. The main reason this capability has been added is to allow users to report the equipment information as has been installed in the building. This will allow reviewers to verify this information against what they see in design drawings. And it also provides a feature where users do not need to convert rated efficiency into COP with supply fan power subtracted. The tool automatically does it for them, and it also allows them to group individual schedule entries into a grouped system for assigning to blocks. Now, once this capability is also present for terminal units and zone equipment. Once all of that has been done, I can move to the HVAC tab where I see the building geometry, and I can drag and drop the grouped system onto a block. So here, again, I get the validation error that every block must have an assigned primary HVAC system. I can click on the blocks, and it would tell me which block does not have a primary heating and cooling system assigned. Now, as you see in the block information, a block can have a ventilation system and a primary heating and cooling system. If a ventilation system is not specified, a ventilation system like a DOAS system is not specified, then the tool assumes that ventilation is being provided by the primary heating and cooling system. And all of these blocks, so this block has a heat pump with a DOAS assigned. And this is a new block that we created, which does not have a heating and cooling system assigned. I can specify thermal zone layout of perimeter and core, and then I can drag and drop the DOAS system to this block, which assigns it as a ventilation system. And then I can drag and drop the heat pump we created, Air Handler 5, to this block. So now we have addressed all validation errors associated with this building. Data entry for this building is complete. Service hot water and operations are two things that are not required for TSPR. Then we can go on the final tab, information, and I can see all the information that I have entered. So this building has 4 blocks, and this is everything that's been specified for this building. If there's anything I want to edit, I can click on the red edit icon and edit it from here. Block 4 is the one that we just created, and I can verify everything that we specified: 2 floors, floor to floor height, floor to ceiling height, the envelope construction, then the lighting power density, and then the heating and cooling system with the DOAS and a primary system air source heat pump. Again, if I want, I can edit any of these properties from that red edit icon I see over here. Once all of this is done and I'm pretty confident about the information, I can click on Score Building. As you see, the other information that's displayed over here is the building information, the building name, and the address, which also you can edit. So if for any reason you wanted to rename your building, you could do it from here. If everything looks good, I'll click on Score. This sends the building to the PNNL server where it is simulated. We run about 6 Energy Plus simulations for each building, with the ideal loads run, the sizing run, then the annual run for the baseline and the proposed. So this can take anywhere from 10 minutes to about 20 minutes, after which you would receive an email with a link to the report for your building. That link will take you to an analysis summary page, where again you'll be able to see all the information that you had entered. You can edit your building if you want to make any changes. For a building that has been analyzed, there is this orange download button that is displayed, from which you can access the Open Studio and Energy Plus models for the building that you analyzed, and you can also download the PDF report. The PDF report has the proposed building TSPR and the baseline building TSPR. It will tell you whether you have complied with the Washington State Energy Code, and as we discussed, that means that the proposed building TSPR should be equal to or greater than the baseline building TSPR. It will have some high-level building envelope information. Then the second page would include the whole building annual HVAC site energy use by end use. So for the proposed and baseline, you have the HVAC energy used by end use for heating, cooling, fans, pumps, heat rejection, heat recovery. This is then totaled to be displayed in kBTU and then also carbon emissions. And you'll also have the heating and cooling loads for the proposed and baseline building. The third section of this report will summarize all the information that's been entered. So the plant loop information, and then for each block, you would have the block dimensions, the envelope properties, and then you would have for each system, you would have the system energy used by end use, and then the system characteristics. So in addition to a whole building TSPR, this tool will also generate a system TSPR, so you can identify which system is performing well compared to the baseline and which system is not. So in this building, we see that at a building level, this building complies with TSPR requirements, but this particular system, which is VAV system 1, has a TSPR that's lower than the baseline, and you can see the system characteristics. Then the second system that was analyzed was a heat pump. And here you see the proposed TSPR is much better than the baseline TSPR for this heat pump system. And you can see the system properties. It also tells you which block has the system assigned, office block 2. And this final section, baseline HVAC system summary, displays the baseline system information which has been analyzed for each block. So here you see block 2, and office block 2 has a water loop heat pump, and you can see the characteristics of the water loop heat pump system with a DOAS. And then office block 1 has a rooftop heat pump with a DOAS, and you can see the system characteristics for this particular baseline system. The final section then has the mechanical equipment schedule, plant loops, everything that was specified for the mechanical equipment schedule information has been summarized here. So the equipment ID, the plant type, the rated capacity, rated efficiency, and also the calculated efficiency. So this is something that can be used by the reviewer to verify information against design drawings. And as you see, all of the information is listed. In addition to what we just saw today with regards to creating a building and analyzing it, as well as walking through the PDF report, the tool also has multiple other capabilities for creating a group of buildings and analyzing them together through a batch run, sharing buildings with your contacts, and also downloading results for a large number of buildings in a CSV format. All of this will be covered in separate tutorial demo videos, and those will be posted on the Washington Code's website eventually. Thank you for listening.
Thank you, Supriya, for providing that click-through and a little bit more background information about TSPR. I'd like to conclude the presentation portion by outlining a few next steps. First, the timeline. The TSPR tool is now widely available. I'll provide this link in the chat in a few minutes here, and you can access the tool through the link. And as I mentioned, the Washington State Energy Code will be adopted on February 1st, 2021. The second point here is there are some pieces of information for your future reference. The first is an introductory flyer that Nia has put together, and I'm just going to put my screen on that. This is a one-page back-to-back informational flyer about TSPR, and it's a good introductory guide that provides some of the basic information that could be used for an initial introduction of the concept to within your project teams, within your group, to an owner or others, if you're looking for a simple guide to be able to share for folks to learn more about what is TSPR, what's required, what kind of systems are exemptions, etc. There's also a quick start guide that walks through getting started with the TSPR tool. I'll also provide a link in the chat to that. And it's a good, really quick reference as you're getting started with the TSPR tool. Within the asset score interface of the TSPR tool interface, there's also a TSPR user guide, and I'll again put that link in the chat. It's a more thorough user guide that's online, web-based, where you can, if you're facing some kind of question about how to handle a situation of going through the TSPR tool, your answers might be within that guide. So I'd suggest looking at that, and it will be helpful for you as you start the journey of modeling in the TSPR tool. Within that guide, there's some guidance on how to simplify real projects into the TSPR tool. Through pilot testing, we found that this can be a challenge to have a really detailed building and then think through, how do I simplify this down to its essence to put into the tool? And the simplification for real projects provides some guidance for how to do that. And I think it'll be a really helpful resource to you. As you encounter questions, if you have them, there are two places to go. If you have questions about the code, you can reach out to the Washington State Energy Commercial Technical Support Team. They have a phone number and a website here. If you have questions about the tool, you can access the TSPR user support through the help desk in the tool. So if you click on the help icon in the tool, it'll take you to this website, and you'll be able to put in your question through that. There will be some future training opportunities. Wednesday, August 5th, we will be doing a similar training to the one we're doing today. Here's the link to the registration. I'll put that in the chat. And stay tuned for a recorded version, both of today's webinar, and also we're going to record a longer click-through training that gets into a little bit more nuance of some things that some places where we've experienced users having questions, and we're going to go into greater depth in those recordings. And we'll be putting those on the Washington State Energy Code educational resource page. I will follow up with you with a link to those once we've put them up. Finally, we'd love your feedback. I'll be sending you an email asking you to fill out a very brief evaluation. I'll copy this link and put it in the chat if you're so inclined to do it now or just after our presentation. We'd love to know what we could do better, what you would have liked to have heard that you didn't hear, and what we did well. So with that, I'm going to turn it over to Duane to help us moderate the Q&A. Thank you for populating that as we presented. And I'll leave this slide up as we're answering the Q&A, so you have access to our contact information, as well as those helplines for questions about the code and questions about the tool. So with that, Duane, take it away.
Heather, I don't hear Duane. Do you hear him? I don't either.
Testing.
So,
Can I do a sound
everyone.
check?
Yeah, we can
Testing.
hear you now. Perfect.
Okay, I was busy there for a minute ending the video. So great job, Heather and Supriya, in going through and introducing TSPR to our attendees. We had a lot of good questions. I think kind of like our first go around, some of the questions are code related. Some of the questions are technical. So I'll chip in on the code related questions and punt to you guys on the technical type stuff. So first of all, Thomas Thompson asked, and this is a code issue for the exceptions of TSPR. Is it a full building area, or can it be just a tenant space less than 5,000 square feet, thinking that tenant improvement projects are often reviewed for code upgrades? I'll tackle this one. The requirement for TSPR is based on the systems serving those specific occupancy types. The exception is for buildings. And so if you've got a building greater than 5,000 square feet that includes that occupancy typology, then TSPR is going to be required only for those occupancy types. So I think it's going to be on a case by case basis, but it is based on buildings over 5,000 square feet, new buildings. And then if you have systems serving those specific occupancies, TSPR would be required. Morgan Heater. Morgan, we did a review of the TSPR analysis tool and found that the energy consumption predictions by the tool were not believable, likely due to unrealistic assumptions for internal gains and schedules. Where are the modeling outputs compared to building data? Is that something, Supriya, you can address?
Yes, for sure. So firstly, just to remind everyone that there is no billing data for TSPR buildings or for any building that meets the new Washington State Energy Code. So we don't really have anything to compare these models against in terms of real buildings. Then in terms of the other part that Morgan's mentioning, that the energy consumption predictions were not believable. This is actually something that we have noticed, not just PNNL, but also on NORESCO, which is doing an additional analysis on the Washington State Energy Code. The new Washington State Energy Code requirements with reduced infiltration and the ERV of 70% efficiency is resulting in extremely low heating energy use. And the fact that there is no building that has been designed to this in Washington State, there is nothing we can compare a model simulation results against. In terms of the internal loads and schedules, these were, the internal loads and schedules are based on standard 90.1 Appendix C, which defines a set of schedules and loads based for use types. And these were decided upon and approved by the stakeholders who were involved with the TSPR code development. When we were developing these requirements for multifamily, we received feedback for modifying those, and those have been modified for the Seattle code. If there are any concerns about this loads used for the other use types, then that'll again have to be changed in the code itself for the tool to be updated. I hope that answers Morgan's question.
Yeah, great, Supriya. I think it also answered a couple other questions Morgan had about the default schedules and the loads. And I would point people to Appendix D in the Washington State Energy Code, which details where those assumptions are. Morgan also had a question about, do you have a comparison of energy results between a detailed Energy Plus model and a TSPR model?
Yes, actually we do. We did do that analysis. So we did compare, so detailed Energy Plus models were developed which meet the Washington State Energy Code requirements. And we compared the simplified TSPR models against those. Of course, the results aren't exactly the same, but they were pretty much well aligned with those. And we can definitely share those in our resources section. So PNNL can work on putting those together and publish them on the tool website. And Morgan, we'll send you a note once we have those published.
Great. Kathy Shoemake, are the building blocks HVAC zones? How does this work with multi-zone systems? For example, with a VRF system, should there be a block for each indoor air handler or for all the conditioned areas served by the condensing unit?
Right. I should have covered this during the presentation and the demo. I missed mentioning this. So, Kathy, if you look into the Washington State Energy Code, it has some guidelines on how to simplify your building. The blocks aren't supposed to represent a thermal zone. They're supposed to represent a portion of a building which has the same use type and is served by the same HVAC system. So in your example of VRF systems, you would just create one block which represents that portion of the building which is served by VRF. For thermal zones, the Washington State Energy Code defines that your thermal zone will either be a single zone per floor, or it would be perimeter and core based on the dimensions. The tool allows you to specify that. So if you create perimeter and core thermal zoning configuration, the tool will add a terminal unit to each thermal zone. You don't need to create a separate block for it. And again, the user's guide has some guidance in this. So if within the block section, if you click on that question mark icon, it'll take you to the section of the user's guide, which explains this process of how to simplify your building geometry and minimize the number of blocks that you create.
I might also add, I added a link in the chat directly to that section. So you can reference that directly if you'd like through the chat.
So Austin Hanks had a question. Does TSPR allow for mixed use buildings?
Correct. Yes, TSPR does allow for mixed use buildings. Just following the block approach, if you have an office and a retail, you can create two blocks, assign the retail use type to one block and an office use type to another block. And we had shown that during the demo as well.
Right. And I would say if there was a use type that doesn't require TSPR, you don't need to include that block. Is that correct?
Right. You need not include that block. There's a capability in the tool where you can check a box which says this surface separates the portion of a building that basically it separates a portion of a building that needs to be analyzed through TSPR from a portion of a building that does not. So for example, if you have a warehouse and an office, you would only analyze the office portion of that building, and the surface of the office portion, which separates office from warehouse, you could just use that checkbox in the tool. We would model that surface as adiabatic so that there is no heat transfer between the outside and the office, which would be the case if you were to specify an exterior wall for that surface.
Correct. Rob Sawyer, what does substantially replace the entire HVAC system mean as an exception? Please elaborate on how much of the system must remain to be exempt from TSPR. That's a good question, Rob, because substantially replace is not defined in the code. So this is going to be a judgment call. If you have an issue, if you're not quite sure, that's something that I'd get prior approval from the jurisdiction or run that by them to determine how they're going to treat that. But there's frankly no guidance provided in the code of what substantially replace means. Phoebe Warren had a question. How are the outside air heating, cooling, and fan loads handled by TSPR's ideal load? I ask because the amount of outside air may vary depending on the HVAC system type. Supriya, you want to tackle that one?
So, absolutely. So Phoebe, the standard schedules and loads that we use for TSPR, which is Appendix C of Standard 90.1, It also defines the ventilation loads in CFM per square foot. These are based on 62.1. So we actually modeled those ventilation requirements for a building based on the use type. And for the ideal loads run, again, we specify those ventilation loads, and the heating and cooling loads are based on, do account for the ventilation requirements. There is no fan component in the ideal load. It's just accounting for the heating and cooling load. So any heat added by the fan is not taken into account for the ideal loads. It's like a pure heating and cooling load, irrespective of the system specification. If that's a little unclear, then again, we have some guidance on the user's guide, and that can help you understand what an ideal load system means.
Great, thank you. We did have somebody in chat ask, would churches be required to model or use TSPR? And that answer is no. Churches is not an occupancy type. Assembly or Group A is not included in the assembly type, so that answer would be no. I think you've already answered this question, Supriya, for Morgan Heater. Are interior walls surface matched or modeled as adiabatic?
I didn't answer that question completely. Interior walls are modeled as interior walls. They're not modeled as adiabatic. The tool automatically recognizes a surface as an interior wall if it is adjacent to another block and the surfaces are overlapping. So we model that as an interior surface. So it's not adiabatic. There is heat transfer between the zones if the thermostat set point between the two zones is different.
Okay. Andrew Peterson asks, when looking at educational occupancies, would a 4-pipe fan coil system with a high efficiency natural gas boiler pass the TSPR? Upon doing a couple test runs and using the tool, it appears that it does not, but some clients with natural gas already available prefer HVAC systems that utilize gas rather than electricity, since in some areas the natural gas are 1/4 to 1/3 the cost of electricity per BTU. So I think in one of your examples, Supriya, you did show a 4-pipe fan system complying with higher efficiency DOAS. Is that correct?
Correct. That was for an office building, but we have done similar analysis for education. And Andrew, we do receive these kind of questions from other users, and the example buildings capability that we're adding to the tool will help with this. So if you have a question on how to get a 4-pipe fan coil system to comply for an education building, you would be able to get access to an example building that shows the configuration of a system that meets the TSPR requirements. That feature is not there yet, but we can manually share that system configuration with you in a few weeks. We're still working out some details, but yeah, it does comply. You need to do a little bit more with pumps, probably with the fan power, in order to get it to meet the TSPR requirements.
Great. That's going to be a great resource for folks looking at compliance. Hoyt Jeter had a couple of questions. In your large office example, where we had the multiple systems, did you provide or look at cost differences between each system that complied? So did you look at differential costs or incremental costs for compliance?
We have not done that, Hoyt, and that is something that did come up at some point of time. One of the stakeholders mentioned it, but we don't have any data like that. I can make a note and share this internally and see if this is something that would be useful to do.
And Hoyt had one other question here. Are the use types required for TSPR the same as the IBC, or is it different? I'll take a stab at that one right now. It's not the same as the IBC, office, retail, education, and libraries, and so it's similar to the way we handled DOAS in the previous code. Is it's going to be a judgment call as to what, and we're hoping to get some guidance before the code goes into effect from the State Building Code Council, so that we can try to tighten the scope up of TSPR. So stay tuned, Hoyt, on that one. And last question I have in the Q&A section, and then we'll check chat real quick, from Artie Gillis. Is there a way to save wall types, or must the user create the wall types each time? or can they save a block for use in future models?
Right. Marty, that would be a great feature for us to add. We've received this request before. Right now, you cannot do that. Essentially, the way we think of it, it would be excellent if there could be a library of components where you could have wall types, HVAC system types, etc., and you could just like drag and add them to your building. We haven't added that capability. It's again on the wish list. So hopefully sometime in the future.
Good question. So looking at the chat, just a couple of things to clean up here from Derek Adiyar. How does TSPR handle retail tenant finish outs where outside air, chilled water, or hot water comes from the landlord-based building systems? Is this considered a district system, or are there exceptions? No, Supriya, are you still there?
I am.
So it's.
I don't see.
Did you hear that question?
Yeah. Could you please repeat that?
Yeah, it's in the Q&A.
Part of it. Yeah.
Okay. How does TSPR handle retail tenant finish outs where outside air, chilled water, hot water comes from the landlord-based building systems, and I think probably loads yet haven't been determined? Is this considered a district system or not?
Duane, I would say this is considered as a district system, and it should not be. It meets one of the exceptions where TSPR is not required, but maybe you can provide some perspective from the code aspect.
Yeah, I think that's going to be another judgment call. Typically, we look at buildings for TSPR, and if it's a retail building, there's already built-in assumptions for the hot water, chilled water loads, lighting, and plug loads. So we should be able to determine TSPR compliance in the core and shell permit for that area. I don't know, Heather, do you have anything to add on that?
Yeah, I mean, this is a question. I think it's a really great question, and it's one that came up through a pilot test that we did of TSPR of how are core and shell buildings handled and how are tenant improvement projects handled. And I think that we're still having some conversation about that. I think that in the case of a tenant improvement, if the systems are all self-contained and not served by the larger building, then they would require TSPR. However, if they're receiving heating and cooling or hot or chilled water from a bigger building, that would be considered somewhat like a district system. So that was my takeaway from conversations that we've had among this team. The case of the core and shell that doesn't know what the tenants are going to be, I think that it will also require TSPR with an assumption of a baseline, like code compliant tenant improvement schedule. So that's my takeaway. And I think, like Duane said, it's going to probably require a little bit of interpretation.
Yeah, I agree. Last question and a good segue from Marcia Carr. Is this in place of ComCheck or in addition to? And I just want to clarify to everybody, in Washington State, we do not use ComCheck for code compliance, but you will still be required to complete the NREC form. So this is a HVAC performance tool. This doesn't exempt you from the mandatory requirements of the mechanical systems or the lighting systems, controls, or the envelope system. So those are all still prescriptive as far as the code goes. So you have to comply not only with the TSPR, but also with all of the other mandatory and prescriptive requirements of the NREC, and there'll be an online compliance tool for you to document that compliance. Let me check. I think
Duane,
that's
there's one
it.
other question as you're
I see that
as you're transitioning. Yeah, well, I was going to say as a kind of a wrapper here that there are a couple questions about, will this presentation be available after the fact? And I want to say and address that. I addressed it by typing it, but I want to say it also verbally that we're going to post this presentation on the Washington State Energy Code resources page under the online training resources. So you can access this after the fact if you want to go through it. And we will also post at some point in the near future, a more detailed click through. So you can look forward to that. And we will also, I'll follow up to the participants of today's webinar with a thank you and some of those links that were in the chat so that you can have them in your email. I recognize that's an easier way to access that information. So you can look forward to that.
Great. Thank you for that, Heather and Supriya. And I just want to say thanks to everybody for attending today. And that will be the end of our webinar.
Perfect. Thanks, Supriya and Duane, for your support. And thank you all for participating today. Have a great afternoon.